Students, welcome back to my channel. Today let us learn discovery of canal rays. It was discovered by Eugen Goldstein and German physicist in the year 1886. Canal rays are also called as anode rays or positive rays. Now why the name anode is because since these rays were generated from anode, that is positively charged electrode, that's the reason why it was named as anode rays or positive rays. So now let us understand the diagram. How is the diagram and what is the apparatus mainly? So it is a discharge tube. So discharge tube is nothing but a glass tube which is made up of a particular gas which is getting ionized by the rays within the tube. Okay, now here the gas taken was hydrogen, and then there was two electrodes. One was cathode and one was anode. So cathode was a negatively charged terminal and anode is positively charged terminal. Now the cathode was perforated, means there were holes inside the cathode so that the anode rays could easily pass through them, and we could and Goldstein could study the cathode rays. Okay, so that's the reason why it was perforated, and behind the cathode was a thin beam of fluorescence. So the fluorescent material taken here was zinc sulfide, so that he could understand the nature of the cathode ray. So hence he made the cathode perforated, and I'm sorry, nature of anode rays. So hence he made the cathode perforated, and behind it was a thin layer of fluorescence material, that is zinc sulfide. So when when the rays fell on the zinc sulfide, he could easily understand the study the nature of the anode rays. Then these electrodes were connected to a high voltage generator, and the pressure was created within the tube was very low. The pressure created within the tube is low because whenever there's low pressure, every particle within the tube could be understood very well. So that's why the pressure was kept low. It was minimized and it was kept low. So this is the main understanding of the diagram. Now let us understand what happened when the circuit was on. So when the circuit was complete, and since there are hydrogen atoms here, hydrogen gas, so when the circuit was complete, what happened was the rays from cathode started moving towards anode. That's mainly, see, cathode is nothing but it's an electrode which is having electron rich material, okay, and that keeps moving towards anode, and this is electron deficient. So as the energy within the electrode started moving from negative terminal to positive terminal, they strike the hydrogen gas. So as they strike the hydrogen gas was ionized. Means we have hydrogen. Ionization means protons and electrons split up. Okay, that is the positively charged particle and negatively charged particle, they split. Now this positively charged particle started moving from anode towards cathode. That's the name why it was given as anode ray. So as they moved from anode to cathode, they penetrated through the cathode, perforated cathode. Okay, so as they penetrated through the perforated cathode, they fell on this fluorescence beam, and then there was a red glow which was observed. And next was the next step was understanding the, mainly there's ionization chamber here, so mainly understanding how the readings are, or how much amount of protons is produced, and also to understand the nature of the proton. So that was the experiment Goldstein performed. Now why when the cathode was not perforated, the anode rays were just hitting the cathode, because of which he was not able to understand the nature. So that's why he made it perforated, so that they can easily pass through the cathode and they can get deposited on the fluorescence beam, and because of which he was able to understand the properties of the rays. Okay, so this is the experiment. So was it called as canal rays? Because these rays were moving through a canal. The canal here is the perforated cathode, okay, a narrow tube. So that's why it is called as the canal rays. or also another name was given was anode, because it was generated from the positive terminal. Now, based on this, there are certain properties of canal rays. So, as we all know, protons is denoted as P plus, and the mass of proton is 1.67 into 10 power of minus 27 kg. And charge on a proton is plus 1.6 into 10 power of minus 19 coulomb. And now, based on the experiment, it was proved that the canal rays travel in a straight line and they carry positive charge. And the third point they observed was they consist of material particles. Now, here, how he proved that it was carrying positive charges, because here, when there was an magnetic field created, sorry, when there was an electric field created here, so as these particles started moving, okay, so let's say this is a positive terminal, and as these, and this is a negative magnetic field, okay, the positive and the negative magnetic field. So as these rays were moving, it was proved that they started deflecting towards the negative region of the magnetic field. So that's the reason how it was proved that these rays are positively charged. And the next is that they consist material particles, means they have a fixed mass and size, and they are definitely dependent on the gas. See, now here initially the gas taken here was hydrogen. So mass of hydrogen, we know it's going to be 1.67 10 power of minus 27 kg. Now suppose this gas, or that's hydrogen, was replaced by nitrogen, then the mass of nitrogen will be according to its atomic number. Okay, so that's why we say that the discovery of proton, or the mass of the proton, is dependent on the gas which is being taken in the discharge tube. So subsequently there were many experiments done with helium, nitrogen, and many other metals. Okay, so it's very clear that canal rays experiment is, or the mass of the proton is dependent on the gas which is taken inside the discharge tube. So this is all about the today's video. Thank you so much, students.